Welcome to Chapter 4, where we dive into the fascinating world of water treatment. Today, we will explore why we treat drinking water and the step-by-step processes used to make it safe and pleasant to drink. Why do we treat water? There are two main reasons. First, to remove aesthetic contaminants that make water look, taste, or smell bad, like iron or turbidity. Second, and most importantly, to remove health-related contaminants. These can be acute, causing immediate sickness, or chronic, causing issues over long periods of time. The first major step in many treatment trains is oxidation. By adding chemicals like chlorine or potassium permanganate, we can force dissolved inorganic contaminants like iron, manganese, and arsenic to form solid particles, which can then be filtered out later. Next is coagulation. Water often contains tiny colloidal particles that carry a negative electrical charge, causing them to repel each other and stay suspended for years. By adding a positively charged coagulant, like alum or cationic polymers, we neutralize those charges so the particles can begin to clump together. Once the particles are destabilized, we use flocculation. This is a physical process where the water is gently mixed. The slow stirring encourages the particles to collide and stick together, forming larger, snowflake-like masses called floc. We sometimes add anionic polymers to make this floc heavier and stronger. After flocculation, the water enters a clarifier or sedimentation basin. Here, gravity does the heavy lifting. The water slows down, allowing the heavy floc to settle to the bottom as sludge. Many systems use angled tube settlers to intercept falling particles more efficiently, ensuring cleaner water moves on to the next step. Even after settling, some tiny particles remain. That is where granular media filtration comes in. Water flows down through layers of anthracite coal, sand, and sometimes garnet. The media traps the remaining floc through straining and adsorption. When the filter gets clogged, we clean it by reversing the flow, a process known as backwashing. For even finer filtration, we use membranes. Think of these as microscopic sieves. Microfiltration and ultrafiltration are great for removing pathogens like Giardia. Nanofiltration goes further to remove dissolved organics, and reverse osmosis provides the highest level of treatment, even removing dissolved salts from seawater. Seriously, filtration removes a lot, but disinfection is crucial to inactivate any remaining disease-causing organisms. We use primary disinfectants like chlorine, ozone, or UV light to do the heavy lifting. Then we use secondary disinfectants like chloramines to maintain a safe, protective residual as the water travels through the distribution system to your tap. The exact combination of these processes depends on the source water. Surface water, which is exposed to the elements, often requires conventional treatment with full sedimentation. Groundwater, on the other hand, might just need green sand filtration to remove dissolved minerals like iron and manganese. Finally, some water requires specialized treatment. If the water is too hard, we might use ion exchange to soften it. We also often add fluoride to help prevent tooth decay in the community. And if the water is corrosive, we adjust the pH or add protective chemicals so it does not damage the pipes or leach harmful metals like lead. To wrap up, water treatment is a multi-barrier approach designed to protect public health and provide aesthetically pleasing water. By carefully combining chemical and physical processes tailored to the specific source water, we ensure that every drop coming out of the tap is safe to drink.